Hi, welcome to this tutorial. I'm going to solve question 4A from Basic Applied Mathematics NECTA paper, and it is from 2017. Right, question says I need to find dy dx given y is all this when x is equal to 2 pi. So let's just write that down. So given y equals ex square root of cos x, everything divided by 2x plus 3 squared. Now, how do we get dy dx? Well, the first thing you need to do is just try and separate all these items over here. And how can you do that? Well, you can apply logs. So we can take natural logs. Okay, so natural log y equals to natural log of all these ex, and then we have square root of cos x divided by 2x plus 3 squared. Okay, now we can apply log rules to separate this. So when we multiply, we add, and then when we divide, we subtract. So let's just do that. So log y equals to log ex plus log natural log of what? How do we write square root of cos x? Well, the other way of writing square root is by having it as power of half, so cos the power half, and then we need to subtract all this. So natural log 2x plus 3 squared. Right, so now we can tidy up and remove the powers, the indices. So natural log y is going to be equal to x natural log e plus, or a half, natural log cos x minus, bring the 2 over, so that's going to be 2 natural log 2x plus 3. Okay, so this will go to 1, and now we have the rest. Now at this point we can now differentiate with respect to x. What do we get when we differentiate natural logs? Well, you will get on top the derivative of what's inside, divide by what's actually inside. Okay, so derivative of dy dx is just dy dx. So I'm just going to write it like that. Derivative of y, so is dy dx, and then you divide with what's inside, so that's 1 over y. Okay, equals to that will give you 1, and then what's the derivative of cos x? That's negative sine x. So we're going to end up with negative here, sine x over 2 cos x minus we got a 2. What's the derivative of 2x plus 3? Well, that's just 2. So 2, and then that goes on top, then 2 times 2, so that's 4. Divide by what? Divide with what is inside, so that's 2x plus 3. Okay, so far we've got that. Let's tidy this up. Well, we can now remove the y and just rearrange this. So dy dx is going to be equal to y, the whole lot, 1. Let's tidy this up even more. So sine x over cos x, that's tan x. So y minus tan x over 2 and minus 4 over 2x plus 3. So that is your dy dx, but you know what y is. That's given at the beginning, so let's just continue. So dy dx is equal to, well, we're going to substitute the y in, so that's e to the power x square root of cos x, everything over 2x plus 3 squared. Okay, so that's just the y, and then we have what is left, 1 minus tan x over 2 minus, beg your pardon, minus 4 over 2x plus 3. Okay, so now you need to find dy dx when x is equal to 2 pi. So when x is equal to 2 pi, okay, what do we get? We get dy dx equals to e to the power 2 pi square root of cos 2 pi divided by x is 2 pi, so that will give you 4 pi plus 3 squared, and then you have 1 minus tan 2 pi over 2 minus 4 over, again, that will give you 4 pi plus 3. Okay, so dy dx is equal to e 2 pi. Now cos 2 pi, let's go 360, that will be equal to 1. So you'll just be left with that, and you will have 4 pi plus 3 squared. And what do we have inside? Well, tan 2 pi, tan 360 is a 0. So you have 1 minus 4 over 4 pi plus 3. So let's just write that down. 4 pi plus 3. Let's rearrange this again. So I'll simplify rather. 2 pi over 4 pi plus 3 squared, and take in the same denominator. This will give you 4 pi plus 3 minus 4 over 4 pi plus 3. We can now simplify. We can see this is the same as this one here. So dy dx is going to be equal to e 2 pi over 4 pi plus 3. And now I'm going to put these together, so that will be to the power 3, and inside the bracket you will have 4 pi minus 1. Okay, thank you for watching.